Hello friends, welcome to your channel Arohi Classes, and in today's video I will explain gain and efficiency of the antenna. So first we will discuss gain of the antenna. Gain of the antenna is a parameter which relates input power to the output power. Okay, so you can write here, it relates input power to output power. Okay, and the formula of gain is maximum radiation intensity of the given antenna divided by radiation intensity of reference antenna. And now see here, in this case we are considering our reference antenna is lossless. The meaning of lossless means input power to the antenna is equal to the radiated power. Okay, because losses in the antennas are zero, so input power to radiated power will be equal to the input power to the antenna. Whatever the power we have applied to the antenna, it will radiate total input power. So um theta phi, where u is the maximum radiation intensity of the given antenna, u suffix m, divide by radiation intensity of the reference antenna, where reference antenna is lossless. So P input divided by 4 pi. Okay, 4 pi ऊपर आ जाएगा, 4 pi um theta phi divided by P input, and we know that the efficiency is nothing but radiated power divided by input power to the antenna, and eta is the efficiency. So P input will be equal to P radiated divided by eta. So यहाँ पे हम P input की वैल्यू रखेंगे 4 pi um theta phi divided by P radiated divided by eta. So it will be equal to eta into 4 pi um theta phi divided by P radiated. This is nothing but the directivity of the antenna. Okay, so we can write here gain of the antenna is equal to efficiency into directivity of the antenna, and in short we can write G equal to eta into D. So this is the relation between gain and directivity and the efficiency of the antenna. G is equal to eta into D. Next topic is antenna efficiency. Antenna efficiency is denoted by eta, and it is equal to the multiplication of three individual efficiency, ER, EC and ED, where ER is the reflection or mismatch efficiency, EC is the conductor efficiency and ED is the dielectric efficiency. Okay, now see here, this is the supply to the antenna. Okay, this is the supply to the antenna, transmission line. The signal is coming through the transmission line, and this is the antenna, and the input impedance of the antenna is Z input. Now if there is a mismatch between Z0 and Z input, Z0 is the characteristic impedance of the transmission line and Z input is the input impedance of the antenna. If there is a mismatch, if Z0 is not equal to Z input, there is a reflection, there is a mismatch, so there will be reflection. The whatever the power we have applied to the input, some power will reflect back. Okay, so there will be, it creates the reflection efficiency. Okay, ER equal to reflection or mismatch efficiency. Okay, and ER is equal to 1 minus mod of gamma square, where mod of gamma is equal to Z input minus Z0 divided by Z input plus Z0, and gamma is nothing but reflection coefficient. Reflection कोफिशिएंट. अगर मिसमैच होगा तो पावर रिफ्लेक्ट होगा, तो वो क्रिएट करेगा आपका रिफ्लेक्शन और मिसमैच एफिशिएंसी. नाउ ईसी इज द कंडक्टर एफिशिएंसी and ED is the dielectric efficiency. Now see, our antenna is generally made up of conductor or dielectric. So when the power is applied to the input, so some power losses take place into the conductor and some power losses take place into the dielectric. That will create your conductor efficiency and dielectric efficiency. In an antenna, it is difficult, if the antenna is made up of conductor and dielectric both, then it is difficult to calculate these two efficiencies separately. Okay, in that case we can write the formula eta equal to ER into ECD, where ECD is nothing but the multiplication of EC and ED, but we cannot calculate separately. So ECD is nothing but the combined losses, the efficiency due to the combined losses into the conductor and dielectric. So we can write here the final formula eta equal to 1 minus mod of gamma square ECD. ओके, आज के वीडियो में बस इतना ही. अगर आपको मेरा वीडियो अच्छा लगता है तो प्लीज़ मेरे चैनल को लाइक कीजिए, सब्सक्राइब कीजिए और इस वीडियो को शेयर कीजिए. थैंक यू.